Hello, a little fun with volume here. So I got some containers. I got this to-go container here, and it is a truncated cone, right? Imagine extending this side up, 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 up. It'll come to a point eventually. So I wonder how I can measure its volume. And then I have my ball jar, wide mouth drinking glass, which I believe is supposed to be 2 cups. So it's got some milliliter measurements on the side too. That's cute. All right, let's see what we got. So ruler here. Let's do the glass first. So I'm going to pretend the glass is a cylinder. Got a little measure with centimeters, and I'm going to go for the inside. Trying to find the largest. It looks like around 7.5 centimeters. This thing does maybe taper slightly. It definitely rounds at the bottom, right? Okay, so I think it's about 7.5 centimeters diameter. And then I'm going to try to measure the height inside. It's got a little curved bottom. It's concave, right? That makes it a little more challenging. So we won't measure completely to the bottom, but close. So outside it's 12 centimeters, pretty darn close. So inside maybe 11.5. All right, let's write that down, see what we got. Not quite ready for a calculator. Let's see. Sometimes I like to have a picture of what I'm playing with. So I've got this cylinder here, and I estimated that the diameter was 7.5 centimeters, and I was estimating the height to be 11.5 centimeters. And if we look up the volume for a cylinder, we're going to find its base, area of the base times the height, pretty standard. So area of the base is a circle, pi r squared times the height. Okay, so I need r, not d. So if we take my d, divide by 2, that gives me the radius. So what's half of 7.5? That would be 3, oops, half, sorry. 3.5 plus another 0.25, so 3.75 centimeters. So the volume should be pi times 3.75 squared times the height, 11.5. Let's see what the calculator thinks about that. All right, so they have a pi button, cool. And times 3.75 raised to the second power times 11.5. And that says 508 what? 508 what? Oh, good question. About 508. Well, this was centimeters, and then I squared it, and this was centimeters, so this would be cubic centimeters, centimeters cubed. And you may remember from the previous section that for water at sea level, 1 cubic centimeter, usually they go cc, so I could say this is 508 cc's, is 1 milliliter, which is also 1 gram. So it looks like my cup ought to be able to handle a half a liter. My cup, which is actually about 2 cups. My glass, there we go, my glass. So that right there would be about half a liter. Yeah, liter. 500 milliliters. Cool. And actually, before I did this, I did fill this to the very top, and then I poured it into a bigger measuring cup, and the measuring cup said it was pretty darn close to 500 milliliters. So I was hoping this would work out like that. All right, let's try the next one. So the next item, let's see, stop share, there we go. Hello. Down here is my truncated cone, right? So I don't know if this is going to be big enough to measure that. Okay, this will measure that way. So I want inside, it's got a kind of a double lip there. It's going to make it a little trickier, but go for it anyway. Start about there. Oops, I'm squishing it. It's tricky. So sometimes when people are measuring objects like this, they have a caliper that kind of clamps onto it so you can get the diameter precisely. But I don't know where my calipers are. I guess I'm somewhere or not. It looks pretty close to 11 centimeters to me. This whole thing is, well, from here to here is 12 centimeters. So inside, yeah, I'm gonna go for 11. Let's take it at a different diameter in case it's got squished over time. Yeah, it's pretty close to 11 across the top. All right, so inside of the bottom, I gotta estimate this way. So right about there. And the nice thing about the bottom is it's got a center point. Pretty close to 8. I'm going to go for 8 at the bottom. Okay, so I have a diameter of 11 at the top, 8 at the bottom, and then we need a height. And there is a way to do it with the slant height. I'd have to look up that formula. I'm going to go for the vertical height on this thing. So different ruler. All right, this one isn't as good, but here's my centimeter ruler. But I can set it flat on the ground and try and get height on this. All right, so it is a little concave in the bottom. I see it indents in there. So 14 from the outside of the bottom to the top. So I guess just a little less than 14 centimeters. All right, let's see if we can figure out how to get a volume on this thing. Green, back, hey. So my neck shape, try it maybe a couple different ways here. Oh no, my battery is low. Thank you. Charge you later. So I've got this. It's a little exaggerated there, maybe not. So here's my shape. And I have a bottom diameter of, I believe I said that was 8 centimeters, and a top diameter of about 11 centimeters. And the height here was just under 14 centimeters. So let's see. How thick is that bottom, maybe? It's probably a few, 2, 3 milliliters. Millimeters, sorry. Yeah, millimeters. 10 to the centimeter. All right, so I'm going to go for 13.7, given that I'm going for the inside volume, centimeters. All right, so the question is, what do I do with this? So I could look up the formula for a truncated cone, see what formula for that looks like. Or I could think about this as a cylinder and kind of imagine an average diameter. Like, what if we were to like straighten out, move that over a little bit. What if we go for like an average on this thing? Something like, all right, we come in a little bit at the top or out a little bit at the bottom. So we kind of make it into a cylinder. So kind of like, I guess my picture's not all that great. Kind of like that's the way the formula works for the area of a trapezoid. We average the top base and the bottom base to get kind of an average height for this thing. So I'm going to try that strategy here first. So that means So let's see, volume, I'm approximating this with the volume of a cylinder. And that means I want pi times the radius squared times the height. And for the radius, I'm going to average these two. So the radius here would be 5.5 centimeters, half of that. Radius here would be 4. So I want an average radius, which would be 5.5 plus 4 over 2, 9.5 over 2, which is, let's see, half of 9 is 4.5. Half of a half is a quarter, should be 4 3/4, 4.75. All right, so I think the volume of this thing is about pi times 4.75 squared times 13.7. And that would be centimeters squared, right, times centimeters, which is going to give me cubic centimeters. And in water, that would also be milliliters. And I did pour some water in this, so we'll see if this comes out to what I thought. I haven't done this calculation yet. Drum roll, please. So let's see, we got pi again, times 4.75 raised to the second power, and then times 13.7, is that what I was thinking again? It's a few millimeters off from 14, yeah, I think so. Let's see what happens. 971, okay, so I was thinking it held a little bit more than that. So either I'm off in my average radius, wasn't a good idea, or maybe that wasn't quite right. Maybe it's like 14, 13.8. No, okay. Anyway, I did fill this earlier to the very top, to the water was spilling out the side, and I let it sit, and then I measured it, and it came out to almost exactly a liter, about 1,000 milliliters. 978 cubic centimeters is pretty close to 1,000 cubic centimeters. So my calculation, my estimated calculation isn't too bad here. I think my water measuring for the volume of this is a little more precise than my centimeter or millimeter measurement going on there. I'm kind of curious about the formula for a truncated cone. I think you'd need the slant height for that. Let's look it up. Truncated, because I don't know the full height of the cone, right? Where would the point be? I can estimate that. Truncated cone. So, well, they do have measurements. There's some different formulas here. Let's go Omni calculator, cone volume. Oh, let's get some interesting stuff there. Truncated cone. Oh, I forgot it's also called a frustrum. That's a cool word, frustrum. All right, so let's see. Truncated cone. Oh, cool. And they're doing inches, but I bet I can switch to centimeters. Centimeters. I want to see the formula, but let's see what they have here. So my height, I was thinking that was the 13.7 centimeters. My bottom radius, that was 5.5, right? Half of 11. And the top radius, I was thinking was 4 centimeters because the diameter was 8. And it's giving me an answer in cubic inches, but we want cubic centimeters, please. And it says 979. Hey, that was pretty close to what I was thinking. It was 978, given I tried to approximate it with a cylinder where I averaged the top and bottom radius. Okay, that's interesting. They're pretty close. Will you tell me about table of contents, truncated cone volume of a frustrum? Tell me more. Oh, cool. They have a formula here. Let's screenshot that and think about that. This is exciting. Actually, I don't want to do that. I want to just copy and paste that, maybe. Yes. There we go. What do we got here? Picture to go with that. 1/3 pi. So thinking about a regular cone, If this is a cylinder, a cone is 1/3 of that. So the volume of a cone, I went over this before, 1/3 pi r squared h. And so we just have a modification on that. So the depth is my h. So they still have a 1/3 pi. And then they have a bit of jiggery pokery here with the radii, top and bottom. And the depth, that must be the height. Let's see, yeah, call that height. H, yeah, a little, they call it H here, but depth here. Okay, what else could it be? I don't know. So pi, and then instead of just the straight r squared, they have the little r squared plus r times big R plus big R squared. Interesting. I used to know the geometry of why that is. I'll have to look at that again. Okay, and anyway, we plugged in our numbers 5.5, 4.5, and 13.7 into their calculator that uses that formula right there. And again, with their, let's see if this is my frustrum, a little exaggerated there, like that. We get little r at the bottom, big R is at the bigger top, and then h would be that vertical height here. Like from the center there down to the center there, perpendicular is the h. And either way, it was close to that 1,000 cubic centimeters that I measured with my measuring cup. So either I'm a little off with the milliliters when I measured that in the kitchen, or my measurements of the centimeters are just a little off. And then we have other problems, right? This thing is complicated in a couple of other ways, right? We have that indented bottom there. And then there's this kind of this lip at the top that expands a little bit. So it's not a perfect cone because it jumps. Zoom out, it jumps a couple times there. Not much, but a little. Close. We're estimating that. Nice. All right. That's it for now. Take care. Be good math. Bye-bye.